Okay, now we on to, okay, that was the end of indefinite integration. I just want to let you know, we see most of those questions there, like those are all past paper questions. So without knowing it, you just finished all of the past paper questions. Yeah. Because I realized when we were doing radians and all of that, the minute I said, like I mentioned past paper, Josh was like, oh gosh, no. And if he was doing that, then that probably meant other people felt like that too. So from now on, I will never tell you if you're doing a past paper. You just do the question. Yes. So you, this whole time, you were doing 3 mark and 4 mark past paper questions. All of them were either 3 mark or 4 mark. So look at you, solving past paper questions. At least I was good. So applications of indefinite integration. Indefinite integration can be used to find the equation of a curve and for kinematics, right? Right. To find the equation of a curve and for kinematics. Kinematics we're not doing right now, but note that integration and differentiation are applied here as well. So let's learn how to find the equation of a curve. Consider these curves here, right? Easy. Consider these 3 curves. 1 curve here, 2 curves. One curve number 1, number 2, number 3. Notice that the equation for this curve on top is y is equal to x squared minus 3x plus 5. The other one, y is equal to x squared minus 3x plus 3. And this one, y is equal to x squared minus 3x. If I gave you each one of these, and I ask you to differentiate each one of them, right? The gradient function for each curve is 2x minus 3. Let me prove that to you. So we know that to integrate something, if I'm given ax to the n, they told me to integrate this. This would become n by a x to the power of n minus 1. So let me just put the bracket. That's how you integrate, right? That's the rule for integration. So if I ask you, what you said?
Miss, I was saying yes, that's the way I integrate.
Wait, what you said? You said something? Can you see what you said?
Miss, I was just saying that's the way we integrate.
That's the way we differentiate. And 2 different things. Integration is the one with the ax n plus 1 on n plus 1. This one where you bring the power to the front and then the minus 1 from the power, that's differentiation. So if I gave you these equations, right? And I ask you to differentiate each one of them. The first one, dy and dx, which is the gradient function. If I differentiate x squared, I'm going to get 2x. If I differentiate minus 3x, I get minus 3. And the differential of a constant, always 0, right? So we don't put the plus 0, it's understood. If I ask you to differentiate this one too, the differential of x squared is 2x. And then for minus 3x is minus 3. This is the same as this. Okay, and I ask you to find the gradient function of this one too, dy and dx. If I integrate x squared, I get 2x minus 3x, I get minus 3. So for this one, why I don't have anything here is because 3 is a constant, right? Differential of a constant is always 0. So notice each one of these curves, it's different, right? The equation for each one is different because this one has a +5, this one has +3, and this one has no constant, right? Or you say the constant is 0. Yet each one of them have the same gradient function. Because according to my rule, this is what I get. So say they gave you the gradient function. So instead of giving you the equation of the curve, they gave you the gradient function, dy on dx is equal to x minus 3. So they gave you this gradient function, and they asked you to find the equation of the curve. You will be like, okay, if I have dy on dx and I'm trying to find y, all I need to do is integrate. We learned that before, right? When I was showing you why we need to put plus c and all of that. So if I integrate this gradient function, 2x minus 3, I'm going to get y is equal to x squared minus 3x plus c. That's a problem though. Why? They asked me, in this case, they're asking me for the exact equation of the curve. The exact equation of the curve, which means I need to find this constant as well. So that's why I said it's a problem, because we don't have the constant here. What is the constant? That is what we need to find. And that's why when I was showing you, when I was telling you about the arbitrary constants and all that, and I said the constant is always unknown unless given further information. And I told you, you'll learn about it in application of integration. This is where we're going to learn about it, right? So if they ask me the exact equation of the curve, I cannot put plus c. So like, remember when you're doing coordinate geometry and you got like, let's say the gradient of the line was 2. So you put y is equal to 2x plus c. But you didn't leave it like that. You had to find the value of c. So same thing here. If you want to find the exact equation of the curve, you can't leave that plus c. You need to find the value of c. So how exactly do we do that? Well, to find the value of c, further information must be given. Just like when you're doing coordinate geometry, they would tell you a point on the line, and then using that point, you do substitution and all of that, and you find the value of c. Same thing you're doing here. They would give you a point that lies on the curve, and then using that point, you'll be able to find the value of c, just like you did with coordinate geometry, right? So example, find the equation of the curve given dy and dx, which is the gradient function. So dy and dx is equal to 2x minus 3, and they also told you that y is equal to minus 4 when x is equal to 1. So this is the point on the curve, right? So recall, the coordinates is in the form x, y. My x value in this case is 1. My y value is minus 4. So this is the point that they're referring to, right? This is the point on the curve. So let's say I have a curve. Let me say like, this here is my point. 1, 2, not the 1. Anyways, 1 minus 4. Using this point, I could substitute it into the equation that I have. So after I integrate, I found out that the equation is y is equal to x squared minus 3x plus c, right? That's what we did just now by integrating the gradient function. But we said we need to find the value of plus c. How do we do that? We substitute the point that they gave us to find the value of c, just like we did with coordinate geometry. So given that the point 1 minus 4 lies on the curve, all you're doing, substituting those values into this equation to find the value of c. So y is minus 4 is equal to x squared. X is 1, so that's 1 squared, minus 3x, x is 1, and then we're trying to find c. If I simplify all that, that's minus 1 minus 4 minus 5 plus 3 minus 2. So c is minus 2. Therefore, the equation of the curve that they want me to find, like the exact equation, is y is equal to x squared minus 3x minus 2. Everybody good with that?
Yes, miss.
Yes,
That was
miss.
okay. 2. One more person answer me. You good, or you want me to do it again? It's just like coordinate geometry, yeah? You want to find the value of C, so you use the point that they gave you and sub it into your equation to find it. Josh, did you do coordinate geometry yet? Yes, no? A bit. So I'm guessing you did it in school, but you probably weren't paying attention, or you didn't, I don't know, you need to practice more. But yeah, this is what we do, right? Similar to coordinate geometry. So like when you practice, whenever you practice coordinate geometry, you'll see that we do the same thing. Given a point on the line, we sub it into our equation and we find it. Uh-huh. Okay, well, I did that with the class already, and I have recordings and all that on Google Classroom, in Google Class. So let's do this. Let's practice it. Can you write down this question, the first one? I can do it with you. Let me know when you finish. I can just okay, let's do this. This is easy stuff, right? Like it's free marks. It's so simple. With some practice, there's literally no reason you should lose marks in this section or any of the sections. But still, you just have to make sure you practice. So they told us that the gradient, a curve, right? They're talking about a curve. They said the gradient function of the curve. So remember, the gradient function is dy on dx. And they told us this is equal to 3x minus 5. They wanted us to find the equation of the curve. I told you to do that. They need to give you further information. What further information are they referring to? They would give you a point that lies on the curve. In this case, they told you the point named Q has the coordinate 4, 8. So the first thing you want to do, to find y is to integrate this. The first thing you want to do is integrate the gradient function. That's how we find y, right? So y is equal to the integral, so that's my integral anyway, of 3x minus 5 dx. So dx means with respect to x, right? All you're doing, applying your rules to integrate this. So I see a minus sign, so I know for sure I'm applying the rule with sums and differences. And what does that rule state? If I have sums and differences, in this case I have a difference, all I'm doing is integrating each individual term using the rule, right? So when I integrate this, I'm going to get 3x squared on 2 minus 5x plus c. Anybody needs me to go through this, like how I arrived at this answer?
No, miss, it's okay.
That's good,
Understand.
miss.
Okay. Nobody? Yes. Wait, yes, you need me to go through it? Oh, yes, I can move on. To go through. Okay. So we know the integration rule. If I have, well, since I have a difference here, all I have to do, according to my rule, is integrate each term. So the two terms I will be integrating here, 3x and minus 5. all you're doing is applying the rule. What rule am I referring to? This one, the one that says ax to the n dx is going to be equal to ax n plus 1 on n plus 1, can't forget your plus c. So that's what we're doing, right? For each term, we're just applying this rule. So 3x, it's understood that the power here is 1. If I integrate that, according to my rule, 3x n plus 1, in this case, n is 1, so that's 1 plus 1. Then this is divided by 1 plus 1. Integrating this one now, that's minus 5. If I see a constant, it's understood that it's x to the power 0, right? Since anything to the power 0 is 1. Plus 1, 0 plus 1 plus c. Of course, you don't leave it like that. You have to simplify even more. 1 plus 1 is 2, so that's how I got 2x squared on 1 plus 1 is 2 minus 0 plus 1, 1, 5x. Okay, nice. So this is, let me call it like the general equation for y. Now I need to find the exact equation of this curve. How do I do that? I use this point that they gave me. So raising this and this. Wait, can I just clear the whole thing?
Yes, miss.
Yes, miss.
Okay. So we know y is equal to 3x squared on 2 minus 5x plus c. We want to find the exact value of c. How do we do that? We use the curve. Let me curve now, the given point. They told us that q lies on the curve. Coordinates of q is 4, 8. So what does that mean for me? Remember, coordinates is uniform x, y. So therefore, x is going to be equal to 4. Y is equal to 8. Hold on, let me check the chat. So now substituting these values into the equation up here. Y is 8. So put 8 here is equal to 3x squared. X is 4. So that's 4 squared divided by 2 minus 5 by x. X is 4. And we need to find c. So now it's just basic algebra. So can anybody tell me the value of c?
1 second, miss. I'm working it out now.
Okay. Yes, c is 4. Therefore, if the value of c is 4, can anybody tell me what would be the equation of this curve? What's the equation of the curve if c is equal to 4? Anybody? This is like the simplest part of this whole solution. Come on, what's my equation of the curve? Why are you not answering me? I don't have to do the exam though. I done my exam, get my grade, and I finished it. So like, by me answering, I don't need the practice. You do. Okay. 8 is equal to 3. 4 squared is 16 on 2. Minus 5 by 4 is minus 20. Plus C, 16 by 3 is 48. So that's equal to 48 on 2, which is 24. 24 minus 20 plus C. So this is, let me just write it down. 24 minus 20 is 4 plus C, and therefore C has to be 8 minus 4, which is equal to 4. You good now? Jules, you good? Yeah. Yes? Okay. Can I clear this now?
Yes, miss.
Yes, miss.
Do the other one for me.
Miss Christian, miss.
Okay.
What was the equation of that curve, miss? Is just 4?
What? Ask your question.
That's miss. Basically, for number 1, the equation of the curve was 4, right?
No, that was the value of C.
So, what was the equation, miss?
Equation C equal to 4.
My equation of the curve is not C is equal to 4. Using this value of C is 4. So my equation is y is equal to 3x squared on 2 minus 5x plus 4. The equation isn't C is equal to 4. I have to use this value of C and put it into this to get the equation of the curve. Do you understand that?
So basically, you just substitute the C into the equation that you had previously.
Yes, that was the purpose of finding the value of C.
That makes so much sense, miss. Thank you.
Well, yeah, you can do that as well. Let me just write it out. If you didn't want to put this one, you could write it as 2y is equal to 3x squared minus 10x plus b. If you're writing this, make sure you write this as well, right? So you're writing this first, and then you would write this if you want to. But don't just leave this out and skip all the way to 2y is equal to 3x squared. Whatever. Okay, do number 2 for me. Right. They asked me to find the equation of the curve. So the first thing I need to do, find y. How do I do that? I integrate my gradient function. So y is going to be equal to the integral of 6x squared minus 1 dx. When I integrate this, yes, I'll get 6x cubed on 3 minus, let me put the 1x on 1 plus c. But if I can reduce, I must reduce 2. Therefore, y is really equal to 2x cubed minus x. So minus 1x minus x, same thing, right? Plus c. You see for the how Catania had minus 1x, Josh had it too. You wouldn't lose marks for that, but the standard way of writing it is just leaving it as minus x. But putting minus 1x isn't wrong, and you wouldn't lose any marks, right? This is just the standard way, right? So we got this, but we need to find the value of c. How do we do that? We use the point, the given point. All I'm doing, substituting my values well, my value of x and my value of y into this equation right here to find the value of c. So a coordinate is in the form x, y. Therefore, x is equal to 2 and y is equal to minus 5. That's what I'm substituting into here. So y minus 5, this is minus 5 is equal to 2 x cubed, x is 2, cube minus 2 plus c. Let's see where. Okay, good. It's all about learning, right? Once you fix it before your exam. But they asked me for the equation of the curve. They did not ask me to find the value of c. The only reason we found the value of c is because we need that value to sub into here, right? So you don't just leave it as c is equal to minus 19. You now have to substitute this value of c into the equation. So what's the equation of this curve? It's y is equal to 2x cubed minus x, and c is minus 19. So this is your final answer. Everybody good with that? Let's do all of them. Okay. Everybody good with this though? This answer?
Yes, ma'am.
You just came in though.
Yeah, but I completely agree with your methodology.
Okay. Next thing I'm wrong now. Okay, he's here. Yes, he's saying. Yeah. Bruh. Jules, how you get minus 19? Could you go through the algebra? Sure. And so we said, in order to find the value of c, I need to use the given point, so the point that lies on the curve, substitute it into this equation to get the value of c, just like we did with coordinates, well, straight line geometry, right? Okay, so this coordinate, they told us it's t minus 5. The coordinate is in the form x, y. Therefore, my value of x is 2, and my value of y is minus 5. These are the two values I'm subbing into this equation. That's how I'm going to find the value of c. So y, we said is minus 5. So I put minus 5 here, is equal to 2x cubed. X is 2. So that's 2 by 2 cubed minus x. X is 2, so that's minus 2. And then we're trying to find the value of c. Minus 5 is equal to 2 cubed is 8. 8 by 2, 16. Minus 2 plus c. So what I have now is minus 5 is equal to 16 minus 2 is 14. 14 plus c. I need to minus 14 on both sides to get c. Minus 5 minus 14 is minus 19. Therefore, my value of c is minus 19. But like I said, you don't just leave this and stop at c is equal to minus 19. That's not what they asked you for. They asked you for the equation of the curve. Therefore, using this value of